Yes, good evening, Doctor. This is my presentation for the proposal of my project, that is cloud forensics in virtual machines for heterogeneous distributed data centers. This is a simple introduction. It is showing the basic statistics of the coverage of cloud computing. Slide number 1. It's reading at 90% of the businesses have embraced cloud computing services globally. 66% of the cloud market is being dominated by Amazon Web Services, Microsoft Azure, and Google Cloud. And it is also reported that in between 2021 and 2022, the cloud computing market had reached up to 191 billion US dollars, with Amazon Web Services taking the greatest percentage of that cloud market share. And it is expected that this cloud computing market is expected to grow up to 376.36 billion US dollars by the end of 2029. It is also reported that the data center growth due to the increased demand for cloud computing services, there is also increased demand for the data centers, the implementation of data centers, and it is projected that the compound annual growth rate for data centers is projected to be at 45% from 2021 to 2026, contributing to 251 billion US dollars by the end of 2026. Now this is some visualization showing showing the cloud security incidents which have happened of the late 2024. And here it is visualized that phishing attacks have been dominant. Phishing attacks have been dominant, taking 73% of the registered records, and user account compromise at 38%. Now, this other graph here shows the cloud market share as of 2022, and Amazon Web Services taking the greatest percentage of 33%. And then other companies, these are other companies like IBM Cloud, a combination of various companies. But as you see that these companies here, Amazon, Google, and Microsoft Azure, they are the one which has the most dominant in terms of provision of cloud computing services to the population. Problem statement: with the enormous amounts of data generated from the cloud within the VM distributed across multiple geographical jurisdictions, security concerns have come up, and also the use of traditional detection techniques such as signature-based and anomaly detection intrusion systems have led to these traditional detection methods rely on a predefined set of known threats with high false positives. Apart from those ones, there are a number of them, because there is also what we call support, the one class support vector machine. The one support vector machine is one of the traditional approaches that are used for detecting crime or malicious attacks. There's also what we call multivariate correlation analysis. There's also what we call hypervisor and virtual machine introspection. So these traditional methods, they suffer from a high false positive rates, plus also the dependency on the predefined set of known threats. So they suffer hard. They suffer hard from detecting new threats. So because of that problem, I propose to develop and implement a framework that can be used by cloud forensics analysts to bypass the complexity of the cloud environment that is consisted of the heterogeneous distributed data centers. And this one also will curb the problem, because now the traditional methods of detecting attacks, it involves the person physically going to the center, to that place, the on-premise kind of network. So it becomes tedious, especially for disputed data centers, for someone to travel across those multiple data centers that are distributed in various geographical jurisdictions. So this proposed framework will help to retrieve data from the various cloud distributed data centers that are comprised of various layers of virtualization, plus the multi-tenancy, which the other traditional methods cannot handle. Objectives of the study. The main objective of the study is to develop a deep learning framework that can be used by cloud forensics investigators to detect crime-related activities from the data generated from the virtual machines that are spread across the multiple distributed geographical locations with the help of explainable artificial intelligence. The specific objective is to build, train, and evaluate a deep learning models, that is feed-for neural network, recurrent neural network, LSTM, and RNA, for evidence detection within the virtual machines deployed in various distributed data centers. Then design and implement an explainable AI technique that can be used to better understand the prediction made by the deep learning models, then to classify evidence, digital evidence, from the high and the huge volumes of data that is generated by the virtual machines spread across various heterogeneous data centers, or spread across various geographical locations. Significance of the study. The framework will help organizations and institutions to identify, investigate, and respond to security incidents that emanate or that are within the virtual machine, such as the inter-VM packet sniffing, denial of service attacks, VM escape attacks, and therefore be able to trace even their source. The source of attacks this framework will help to trace the source of such attacks, and also better understand the scope or the magnitude of those attacks. Significance number 2, cloud logs or network logs, data generated from the VMs within the data centers, will help institutions to come up with stronger policies and build strong security systems and defense mechanisms to block such similar incidents in the future. Then significance number 3, it will also give the factors that are responsible for such attacks coming into effect. So this one will be very helpful to build the AI trustworthy systems that will allow forensics investigation teams to quickly understand the deep learning algorithms, how they reached such conclusions. Literature review. This is the first paper. It incorporated what we call DNN, CNN, and LSTM in order to demonstrate the performance in detecting the denial of service attacks in the cloud environment. This second paper used what we call convolutional neural networks to detect network intrusions within the cloud environment. One of the problem with this model here, it performed well with non-traditional networks or the non-cloud networks, or the on-site networks, but it didn't perform well with the virtualized environment or with the cloud networks because of the high encapsulation protocols. That is Kanav, Geneve, and NV-Grey. Geneve, it is the same as generic network virtual encapsulation, then I think this one is supposed to be virtual extensible LAN. It's virtual extensible LAN. It was a mistake. Virtual extensible LAN. And then there is network virtualization for generic routing and encapsulation. These are protocols that come within the cloud or the virtualization environment that hinder the conventional network generalization and detecting complex patterns within the dataset. That's why it didn't perform well. It didn't perform well with these protocols. This other paper, it used what we call a hybrid framework that was built by combining what we call a gray wolf optimization, GWOL, and a convolutional neural network to detect anomalies within the cloud networks. The hybrid model, the hybrid planning models was built on the DAPA 98 and KDD 99. I think 98 and 99 means the number of features that are embedded within those datasets. So I displayed performing an accuracy score of 97.92 and 98.42 on both datasets respectively. Then this other paper here, it used what we call an in-text system that was built to detect unknown malware using virtual machine introspection and memory forensics with the use of VMM as the hypervisor. This one, it utilized machine learning algorithms to detect malignant and malicious executables by analyzing the state of the VM memory. So it was just capitalizing on leveraging ML models to achieve high detection accuracy and reducing on the false positive rate the false positive rate in the cloud environment. Methodology, we shall involve the use of the loading of the KVM dataset here there are two datasets which I'm supposed to use, but I realized that KVM dataset has more features than the Open Nebula dataset. So the Open Nebula dataset has few parameters, but the KVM has a number of parameters. So I'm anticipating to use that dataset because it will bring out the true picture of the. Then I'll do what we call data pre-processing and analysis. And then I'll do model building and training, then model prediction and evaluation. Then from there, I'll apply what we call the explainability or explainable AI to explain the black box nature of the deep learning models. So those are the neural networks I'm planning to build. That is FFN, NN, CNN, RNN, and LSTM. This is just some literature about how I'm going to the architecture. This is some architecture about the FN of the deep learning models, the architecture. For example, the convolutional neural network is going to be implemented on 4 layers, whereby the input layer will have 50 neurons. The 2 inner dense layers will have 100 neurons, and then the output layer will have only 1 neuron using the sigmoid activation function. This is the framework of the model, how it's going to be built. The framework shall have the input features. We shall input the features. The features in that dataset, they are like 43. So inputting the features into the model, then I'll perform what we call model data cleaning. Actually, before I'll have to do what we call data pre-processing and analysis. I'll have to clean, then I have to perform what we call an EDA. EDA, exploratory data analysis. Then after cleaning, I'll do model building and training. I'll train these models between 50 and 100 epochs. And then I'll then do what we call model prediction, then evaluation. Then I'll have to apply the explainable AI. Yeah. So application of explainable AI on deep learning models, we shall have to visualize this. We shall have to visualize this after successful implementation. I shall have to visualize these ones on the line plots and the force plots for the sharp and line explainable AI techniques respectively. So these are the references. And this is the work plan and detailed budget. Maybe doctor, you'll advise me on how to come up with the budget and the detailed work plan, because I'm seeing the budget and the work plan should span across 1 year. So guide me on the various slots I should put in each and every part. The work plan, how to come up with a work plan and detailed budget for this application of mine, which I'm going to make, so that I get some funding for this project. Yes, doctor, that's my presentation. I beg to stop. Thank you, doctor, for all what you've done to help me. Thank you.